statement Sn, which is 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus dot 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 plus 1 over n times n plus 1 is equal to n over n plus 1. Alright, this is what we want to try and prove. Alright, so let's try and do this. I'm sorry, for n greater than or equal to 1. Alright, so this statement is already written in mathematical form. We don't need to convert it into an equation since it already is. So let's go straight into the proof. Okay, so we're going to start out with the base case. Base case, I want to show true. Let me write that properly. Show true for the first candidate, which is n equals 1. So for the base case, we're basically showing that if we substitute 1 into the equation on the left and the right, do we arrive at an equality, right? So I want to show S1 is true. Alright? So either you can just grab the first term or plug in 1 here. Let me do the long part. Plug in 1 there. Okay, so 1 over 1 parentheses 1 plus 1 is equal to what I get when I plug in 1 here. So 1 over 1 plus 1. So is 1 over 2, this is 1 times 2, is equal to 1 over 2. Is 1 over 2 equal to 1 over 2? It absolutely is. Checks out, our base case is good. Now we're going to go into the inductive step. So inductive step, basically what we're showing here is that we pick an arbitrary n value and assume that that's true. Does that follow that the next step, which is n plus 1, is true? Okay, so for inductive step, we must show that true for n by assumption follows that n plus 1 is true. Okay, so that's the goal. Alright, so the first part of inductive step is the inductive hypothesis. We're going to pick an arbitrary n value and assume that the statement is true for that. Okay, for that n value. So for the inductive hypothesis, assume that n is true. Okay, assume that n is true. So what is that going to look like? For n is true, we just need to show that s of n is true. Alright, so we're going to assume that the original statement, which is 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus dot 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 plus 1 over n times n plus 1 is equals n over n plus 1 is true for all positive integer values of n greater than or equal to 1. So we're going to assume that this is true. Now based on this hypothesis, we need to now prove that our assumption follows that. So we're going to show that the assumption follows that n plus 1 is true. Okay, so that's what we're going to do. Okay, so basically what we're showing here is that Sn plus 1 is true, right? So when I show that S of n plus 1 is true. Alright, so let's rewrite this statement in the Sn plus 1 form. So it's going to be 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus plus 1 over n times n plus 1. What did I just do? I just copied this left side down, okay? Now I'm going to add on the next term, okay? Let me put it in blue. So what I'm going to do is, I'm just going to replace the n's with n plus 1. So I'm going to have 1 over, instead of n, it's going to be n plus 1. And on this side, bracket n plus 1 plus 1. Oh, sorry, bracket there. All right. Now, is that equal to, on the right side, all I'll just do is replace n with n plus 1. Is that equal to n plus 1 over n plus 1 plus 1? Okay, if I can show that this is equal to that using my assumption, then I'm done. All right. All right, if I take a look at the left side of my inductive, of my proof, this component right here, this component, let me do that properly. That component is the left side of my inductive hypothesis, so I can substitute it with that right there, okay? So it's basically gonna become n over n plus 1 plus, let me start simplifying this side right here, okay? This becomes n plus 1 times n plus 2 because just combine this one and this one is 2, okay? On the right side is going to be n plus 1 over n plus 2. Now to combine these two, we need to find the LCD, okay? The LCD of n plus 1 and n plus 1 times n plus 2 is n plus 1 times n plus 2, okay? So this side, in order for the denominators to match, I need to multiply it by what makes it become the LCD. So this one is missing n plus 2 down here. So in order not to change the problem, I'll multiply the bottom and top with n plus 2, okay? All right, so it's going to become, on the top, it's going to become n squared plus 2, oh, sorry. Let me swap out my colors, my markers. Use this calligraphic pen. So it's going to become n squared plus 2n over n plus 1 times n plus 2. Remember, multiplication commute, so it doesn't matter the order I write it, plus 1 over n plus 1 times n plus 2 equals, the right side is simplified as much as possible, so no work is needed here. We'll just keep dropping it down, okay? All right, on the left side, we can combine the numerators. We're going to have n squared plus 2n plus 1 divided by n plus 1 times n plus 2. Now, the question is this a factor? Are any of these a factor of that? I have no idea. So what we need to do is we need to factor n squared plus 2n plus 1. Okay? So I'm going to use the x game. AC is 1 and B is 2. The numbers that work are 1 and 1. So I'm going to have n squared plus n plus n plus 1. If I factor by grouping, break it down the center. Take out n. I have n plus 1. And then just take out 1 here and I have n plus 1. So we're going to have n plus 1 times n plus 1. Okay, or n plus 1 squared, doesn't matter. So let me put that here. I'm going to have n plus 1 times n plus 1 divided by n plus 1 times n plus 2. Alright, that equals n plus 1 over n plus 2. Okay, if you look on the left side, you see that these two match up. So I can just cancel this and that. One time. And you're left with n plus 1 over n plus 2 equals n plus 1 over n plus 2. Alright, so since the left-hand side is equal to the right-hand side, that is exactly what we want. Alright, so since truth for n follows that n plus 1 is true, the original statement, the original statement is true for n greater than or equal to 1. Okay? Alright, thanks for paying attention to this presentation. You can see, please subscribe to my videos and you can see the collection of my clips. Just go to www.math.serve.blogspot.com and you can see other videos that I have there. Okay, so there you go. That's it for mathematical induction for today.